All right. This will be our second trig test review. Yep, that looks right. Okay. Verify each identity. When doing verifications, it's all about showing your work. It's not like we're trying to get one answer. The work is the answer. I mean, this identity is assumed to be true. We just have to prove it. So when we swap things out, we use letters to kind of let the reader know what's going on here. In number one, if I want to replace this tangent with sine over cosine, I just used a quotient identity, so I write a q there. If I want to replace this secant with a 1 over cosine, that's a reciprocal identity, I write an r there. Why did I pick these two to do? Well, the reciprocal identities and the quotient identities help us decompose into sine and cosine. And I want to focus on the more complicated side and try to make the more complicated side look like the simpler side. It's always a little bit easier. All right, I've got a fraction divided by a fraction. I'm going to copy dot flop that. So I copy the top, write a dot, and then flop the bottom. From here, we can cross simplify. Now I've just got that equals sine x. Actually, I want to write it below here. Just equals sine of x, and then this sine of x carries all the way down. So sine of x equals sine of x. This is sufficient to get the points. It doesn't say find the domain of validity. We'll do it. I will do that with just this one, and then we'll skip it. What I do is I write out the ratio for each. Tangent is opposite over adjacent. Secant, being the opposite of cosine, is hypotenuse over adjacent. And sine is opposite over hypotenuse. Adjacent is the only side length that appears in the denominator, and adjacent is 0 when our angle is of the form n plus 1/2 pi, where n is an element of the integers. Well, we don't want to divide by 0, so we're going to exclude that from our domain. X cannot equal that. There's our domain of validity for that one. Number two, let's see, decompose into sine and cosine. This left-hand side is going to become cosine divided by cotangent is the same as 2 cosine over sine, or at least cotangent's the same as cosine over sine. 2 cotangent would be 2 cosine over sine. I just used a quotient identity, so I write a q. Let's copy dot flop, so copy the top, dot, flop the bottom. These cosines will cancel, and now I've got sine of x over 2. Copy the sine of x over 2. The left equals the right, draw a little box. All right, let's tackle one of these harder ones. I think maybe number 4 looks to be a tad bit harder. We got that fraction. I can work with both sides, or I can just work with one side to try to make it look like the other side. I think this one maybe it would be the easiest to work with both sides, so I'll do that. Try to do it the easier way. First thing I'm going to do is a reciprocal identity on cosecant to make it 1 over sine. A quotient identity on cotangent to make it cosine over sine. A quotient identity on tangent squared to make it sine squared over cosine squared. Notice the squared carries. And then sine is, we'll just leave as sine. Notice I've stopped writing the x's. That's just to save myself a little bit of time. Let's combine by multiplying straight across. I've got 1 over cosine over sine squared. And then over on this side, I've got sine cubed over cosine squared. When I add the sign on top, copy dot flop this one. Now I've got sine squared over cosine equals sine cubed over cosine squared. Have I made a mistake? I don't think so. Always good to kind of, oh wait, this was a cotangent squared up here. So that should have been a cosine squared sine squared. So when I combine this, that should have been cosine squared sine cubed. When I copied off flopped it, it should have been sine cubed cosine squared. Now they match. Instead of trying to force the issue, I went back and found my mistake. That's what you should do too. You think you've made a mistake. Or if it just isn't looking quite right, you know, if 2 or 3 steps in, you don't quite see the path of how to solve it, then go find your mistake. That's what I had to do there. But I caught it pretty quick. All right. Verify they didn't state the domain of validity. Okay, we'll just do one more. Cosine, I'll leave that as cosine. Cotangent, I'll turn that into cosine over sine. Plus sine equals, I'll just leave that as cosecant, actually. I'll just leave the right-hand side untouched and only manipulate the left-hand side. This cosine is going to come on top, make it a cosine squared over sine plus sine equals cosecant. To combine these, I need to get a common denominator. You can think of this as a sine over 1. So to get the denominators to match, I need to multiply it by sine over sine, so they both have a sine on the bottom. Now I've got cosine squared over sine plus sine squared over sine. Now that the denominators match, I can add the numerators. Cosine squared plus sine squared all over sine equals cosecant equals cosecant. Here, this now I can use the Pythagorean identity. So I'll write a P to turn cosine squared plus sine squared into just a 1. 1 over sine equals cosecant. And then use a reciprocal identity to get this to cosecant of x equals cosecant of x. Draw your little box. Domain of validity. Above each of these, I'll write the ratio. Cosine is adjacent over hypotenuse. Cotangent, adjacent over opposite. Sine, opposite over hypotenuse. Cosecant, hypotenuse over opposite. Opposite is the only one that appears in the denominator. That means that x cannot equal n pi, where an n is an integer. All right. Moving on, final solutions to each equation in radians. To do this, I'm going to need to use inverse, trig functions, and also draw some pictures. Let's start with number 6. I take the inverse tangent of both sides. Now I have theta equals the inverse tangent of negative square root of 3. I'm going to make that a negative square root of 3 over 1 because it's a lot easier to work with this if it's a fraction. Let's draw a diagram like this. Let's actually draw a smaller diagram too that we label all students take calc. This is a negative number here. I'm looking for when tangent is negative. That happens here where only sine is positive, and here where only cosine is positive. Now let's remind ourselves what tangent represents. Tangent is always opposite over adjacent. So I want to put a triangle into this quadrant and this quadrant here, where the opposite is the square root of 3 and the adjacent is 1. That's going to look like that. In fact, well, this one, the adjacent will be negative 1 and the opposite would be square root of 3, so the negative's on the bottom there. Over here, exactly 180 degrees later, this would be negative square root of 3, and that would be positive 1. That angle in there is a 60-degree angle, making this angle out here 120 degrees, which also equals 2 pi over 3. This one's exactly 180 later, so the thing about tangent is that once you find one angle, you can just say 2 pi over 3 plus pi n, and now you've got all the angles. And that is the full solution here. For number 6. Is there a difficult one? Maybe 10. In 10, we've got some more operations, so we just have to undo them. I'll divide both sides by 2 to get started. I have tangent of 3 theta equals -1. Take the inverse tangent of both sides. And now I've got 3 theta equals the inverse tangent of -1. Our diagram would be good again. Let's make that a -1 over 1. Let's do an all students take calc diagram. Tangent is negative here and here. And then let's remind ourselves this is opposite over adjacent. So I need to draw a triangle into this quadrant where the opposite over adjacent is equal to -1. So I'll just make this a 1, -1, square root of 2. That's a 45-degree angle triangle. The angle to get to that terminal side from our initial side in radians then would be 3 pi over 4. So inverse tangent of -1 is 3 pi over 4 plus pi n. Let's fill that into our equation. So we still have this 3 theta over here. 3 theta equals 3 pi over 4 plus pi n. Divide both sides by 3. And we get theta equals, those 3's would cancel out. This would just be pi over 4 plus pi n over 3, where n is an integer. Say we want to check and see if this is a good answer. Well, here's what I would do. I'd set my calculator into radian mode, since this is radians. I'd pick any integer, maybe, I don't know, 6, and then I'd plug that in. And here I'll just kind of say it out loud. So 2, all right, so I get mode, radian, 2 times the tangent of 3, and then for theta, I'm going to do pi divided by 4 plus pi times, we said we'd pick any random integer, let's pick the integer 5, divided by 3, close parentheses, hit enter, and I do get a -2. All right, so we just picked a random integer, plugged it in, plugged this whole thing in for theta, and it made the equation balance. All right. Yeah, number 11 is pretty similar. Let's do number 12. Find the shadow cast by an 11-foot lamppost with an angle of elevation of the sun of 58 degrees. Find the length to the nearest tenth of a foot. So let's draw a good diagram. Here's our lamp post. Just make it really obviously a lamp post. I don't know. A ball on top. There, that's a lamp post. It is 10 feet tall. The angle of elevation to the sun is 58 degrees, so that's this angle down here. And then find the length to the nearest foot. Okay, wait, oh, the shadow is 10 feet. The shadow is 10. Find the length to the nearest foot, presumably of the lamp post. So this is my opposite side. I have the adjacent side. The trig function that connects opposite and adjacent is tangent. So tangent of 58 is equal to x over 10. Multiply 10 to both sides. This one, make sure you're back into degree mode. 10 times the tangent of 58 degrees. Make sure you're in degree mode. I'm getting 16 feet. Rounded to the nearest tenth of a foot because it's 0.00. All right. solve each triangle. Round your answer to the nearest tenth. So solve means find all of the unknown angles. We can start with a really easy one. We can find this angle here by just subtracting the two other angles from 180. So 180 minus 48 minus 38 is 94. 94 degrees right there. To find these side lengths, we can set up law of sines. I'm solving for a side length. I'll label this little b, little a. So I'm going to put those on top. Little a divided by the sine of 38 should be equal to, and then I use side length C and angle C because I know both of those. So 35 divided by sine of 48. Multiply sine of 38 to both sides. And we get A equals 35 divided by the sine of 48. Press enter. Multiplied by the sine of 38. 28.99. We'll just round that up to 29 feet. Last one to get, again, we'll use law of sines for it. Little b divided by the sine of 94 equals, we can use either of these. I'll do the same one I did last time, 35 divided by sine of 48 times sine of 94 times sine of 94. Plug that into your calculator. 35 divided by sine of 48 times sine of 94, 47 feet. 47 feet. And now we've got all three pieces of information there. We can do law of sines with number 14. We can't do law of sines with number 15. We don't have an angle. The only option is to use law of cosines. So I can pick any angle that I want to solve for. I'll solve for A. Let me copy down my formula. A squared equals B squared plus C squared minus 2BC cosine capital A. And now fill in what I have. This is little a, this is little c, this is little b. All right, 13 squared equals 12 squared plus 9 squared minus 2 times 12 times 9 cosine A. 13 squared is 169. 12 squared is 144. 9 squared is 81. Minus 2 times 12 is 24 times 9, 216. Cosine A. Now recognize that 216 is the coefficient of cosine A. You cannot combine it with these over here. These have to be moved over one at a time. Minus 144, minus 144, minus 81, minus 81. You get 169 minus 144 minus 81 equals negative 56. Negative 56 equals negative 216 cosine A. Divide both sides by negative 216, divide by negative 216. And we get 0.259 equals cosine A. I just leave that in my calculator so I can do inverse cosine on it. So second cosine, second answer. We'll do the inverse cosine of the answer. So second cosine, second answer. 75 degrees for angle A, just about. All right, to find another one of these angles, now we can do the quicker law of sines. Now that we have an angle and the side length opposite of it. So I'll solve for angle B now. Law of sines, sine B divided by its opposite side, 12, should be equal to the sine of A, which we just solved to be 75, divided by its opposite side, which is 13. Multiply 12 to both sides. Sine 75 divided by 13 we're getting sine of b, capital B, equals 0.074. Take the inverse sine of both sides. Second sine, second answer. 4. No, that doesn't make any sense. Where did I make a mistake? Let me redo some of this work. All right. Sine of 75 divided by 13. Oh, I never multiplied that by 12. Okay, so at 0.074, I've got to multiply it by 12. That number should be 0.888. Now I do the inverse sine. I get 62.6 degrees for angle B. 62.6, and now I can just do triangle sum to get the last one. So 180 minus 62.6 minus 75, I get 42.4 degrees. Let's see how we did on 15. Okay, we just rounded just a little bit more. They've got 63 and 42. Or they rounded more than we did. Let's move on. Find the exact value of each. Don't forget to rationalize your denominators. Use angle sum / difference identities. Here we go. Definitely want your purple packet out here. 255. Let's copy down just a column of all of our angles from the unit circle. Might be something you want to have on hand when doing these. 120, I always skipped 135. 150, 180, 210, 225, 240, 270. Now we've exceeded that number. So let's see, is there a way to combine two numbers in here to get a 255? I'm thinking one way to do it would be a 210 and a 45. There's probably another way. Maybe with the 135 and the 120. Yeah, that works too. But I'll do the 45 and the 210. You can try a different way, see if we get the same answer. So I'm going to rewrite this as cosine not of 255, but of 210 plus 45. Now I can use the cosine addition formula. Let me write it off to the side. Cosine of A plus B is equal to, looking in my packet, cosine A, cosine B. It keeps the same sign. No, actually, it flips the sign, so it should be a minus. Sine A, sine B. So let's plug that in. 210 is my A. 45 is my B value. So now what do I have? I've got cosine of 210, cosine of 45, minus sine of 210, sine of 45. Sketch a really crude 210 angle just to have the right side lengths. This would be a -1, 2, and a negative square root of 3 triangle. A super crude 45-degree triangle would just be 1, 1, and the square root of 2. Now I can fill these in with the correct ratios. Cosine of 210 adjacent over hypotenuse, sine of 45, opposite over hypotenuse, sine of 210, opposite over hypotenuse, -1 over 2 sine of 45, 1 over root 2. And now we're just off to the races with simplifying. This can be negative root 3 over 2 root 2 plus the minus and negative will cancel out 1 over 2 root 2. This here equals negative 3 plus 1 over 2 root 2. Time to rationalize the denominator by multiplying the top and the bottom by the square root of 2 over the square root of 2. So now this is negative square root of 6 plus the square root of 2, all divided by 2 times 2. Last thing for this one, let's just combine those in the bottom. Negative square root of 6 plus root 2 all over 4. Let's see how we do on 17. Negative square root of 2 minus square root of 6. Is that what we had? Yeah, we just had it in a slightly different order, but that works. All right, verify each identity. These use the double angles. I think we did 19 in class, actually. You can look for that one in the notes from that day. Let's look at 20. See if there's anything that really jumps out. I am thinking, all right. Not positive on 20. What's going to work out, but I'm willing to give it a go. One identity that I think I'm going to use is this one here. Cosine of 2. Well, that's just, yeah, cosine of 2x equals, which one would work best? Yeah, cosine of 2x equals 1 minus sine squared of x, just straight off the purple sheet. I'm going to substitute that in there for cosine of 2x. So when I do this, I just used a double angle, so I should write an arrow with the letter D on it. 1 minus, in parentheses, 1 minus sine squared x. Cotangent. I can see a tangent squared over here, so I'm actually going to use a reciprocal identity on that one so I can get the tangent squared to make this a 1 over tangent squared x. All right, and this one actually comes together pretty quickly. That 1 distributes. These 1's cancel out. So I'll write it 1 minus 1 plus sine squared x all over 1 over tangent squared x. The 1 and the minus 1 cancel out, copy dot flop, and we're going to get sine squared. I lost a 2 somewhere. Yeah, this is 1 minus 2 sine squared x. So there should be a 2 there. 2 there. So 2 sine squared x. Copy dot flop brings the tangent squared x up, and now that just equals that. We were able to make a match. Exactly. Don't expect a lot of double angle stuff on the test. I just want you guys to have some exposure to it. So this one has been verified. I used a double angle and a reciprocal identity, and then just canceled, copied out, flopped, and was able to make it work out. Number 22, I think I'm going to do that one in class. Let's do, oh, but I think I did 21 in class. I guess we should do 22. This one's clearly using a half angle identity. So I I've got to, 22.5 is clearly 45 divided by 2, and that's nice because 45 is on the unit circle. So I want to rewrite this as the tangent of 45 over 2. I'm going to write down that identity tangent of theta over 2 equals plus or minus the square root 1 minus cosine theta over 1 plus cosine theta. 45 is in the position of theta, so this here equals the square root of 1 minus cosine of 45 divided by 1 plus cosine of 45. Notice I left down the plus or minus. That's because I'm going to figure out if it's plus or minus right now just by using all students take calc. 22 is in the all quadrant, so I know this is going to be positive. I don't have to keep writing the plus or minus. All right, let's simplify that. Cosine of 45 degrees is going to be square root of 2 over 2, so I've got square root of 1 minus square root of 2 over 2 over 1 plus square root of 2 over 2. To simplify this, I need to get a common denominator. That denominator is a 2. So now we're off to the races on simplifying. This is our precise answer, but it's just not simplified. It's not what the answer choices are going to look like. Here's how we would simplify that. I need to make common denominator, so I make that 1 a 2 over 2, minus root 2 over 2. This one down here is going to become a 2 over 2, plus root 2 over 2. And now that I've got those common denominators, I can make this 2 minus root 2 over 2 all over 2 plus root 2 all over 2. I can copy dot flop, but essentially these 2's will cancel out. And now what do I have? I've got the square root of 2 minus root 2 over 2 plus root 2. I've got to multiply by a conjugate here. To simplify this, 2 minus root 2 is my conjugate. Foil on across the top and the bottom, and we'll get square root of 4 minus root 2, or minus 2 root 2 minus 2 root 2, so that's a minus 4 root 2 plus 2, and I multiply the negative root 2's. And on the bottom, 2 times 2 is 4. The middle terms cancel out, and then I get a minus 2. Let's keep going. Now we got minor like terms. We'll have 6 minus 4 root 2 all over 2. Actually do that, divide by 2. We'll get the square root of 3 minus 2 root 2. And now whoever figured this out, I can't take credit for it. It's really an ingenious way to simplify this. We break the 3 into a 2 and a 1. So we're going to make that a 2 minus 2 root 2 and a plus 1. Now that 2 can be rewritten as the square root of 2 squared minus 2 root 2, a perfect square. This is the square root of 2 plus 1, no, wait, minus 1 squared. Let me just double check that. Yeah, first, outside, inside, last. And now the square roots cancel out. And I'm left with the square root of 2 minus 1. Final answer. All right, that'll be good for this video. Good luck studying. See you for the test.